This is a Rubik's Cube. Everyone knows what they look like. Not many people know how to solve them, but have you ever wondered how they work? Well, I did. So I took to reverse engineering the mechanism behind the iconic 3x3 puzzle and 3D printed my own. Let's get started. How's it going, guys? Angus here from Muse. I've been 3D printing puzzles and mechanisms for a while here on YouTube, and having a go at the famous Rubik's Cube was heavily requested. The history behind this infuriating puzzle is actually really interesting. It was invented in 1974 by Erno Rubik, a Hungarian architect who wanted a working model to help explain three-dimensional geometry. That's right, at first this was never even meant to be a puzzle, but a method of visualizing movement of interlocking objects in 3 dimensions. After scrambling his new puzzle, however, he realized he couldn't actually solve the thing, and that's no surprise considering the 3x3 Rubik's Cube has 43 quintillion possible states. That's 10 to the power of 18. Yeah. Eventually, though, he did figure out a method of solving his invention, and the iconic puzzle was born. Something that always fascinated me as a kid was the ability for the pieces, specifically the corner ones, to be rotated and migrated around the cube without the whole thing just falling apart. I had to find out how it worked, so I tracked down the original patent. The puzzle consists of 4 distinct parts: a corner, edge, and middle piece, which are known as cubies or cubelets, and the core, which holds the whole assembly together. Armed with images from the patent and some basic sketches, I drew this up, my first crack at the 3x3. Its dimensions were based off the existing puzzle, and I owe a big shout out to RC Pongo, whose Blender tutorials helped me get started, although I can't use Blender to save my life, so I drew mine in Fusion 360. He's got loads of really cool 3D printed puzzles, and he's been doing this sort of thing for ages, so if you find this sort of thing fascinating, definitely go check him out. So with great pleasure, let me introduce you to the world's worst 3x3. Everything about this puzzle sucks. The core stripped instantly with the M3 screws, and the parts jam up against each other. So when you rotate it, eventually it just explodes. But the mechanism does work. You can clearly see that spherical shape I was talking about. Each cubie has a small part of that sphere which extends beneath the neighboring parts. The middle pieces are key to locking the whole puzzle together, and they're secured with a screw in my case. And that's also an important part to understanding the overall mechanism. The middle cubies don't move, they simply rotate in place. So with ill-deserved confidence, I set out to make a new design, better and larger. The biggest issue with 3D printing these parts was the support material needed, which greatly affected surface finish and thus the movement of the final puzzle. To solve this, I modified the corners and the core to look like this. I've demonstrated in the past on Maker's Muse that 3D printing of overhangs is very much possible if you apply clever design, and this modification does nothing to affect the final movement, but it does make the parts far easier to 3D print. Unfortunately, the middle and edge pieces do still need support material, but it's easy enough to remove from flat surfaces. By the way, if you're still watching, you're probably pretty interested in puzzles like this, and I highly recommend checking out Nathan Wilson's channel. His approach to making puzzles is far more manual than me, and one of the more tedious parts of his builds is the stickering. Honestly, I don't know how he has the patience because, quite frankly, I couldn't be bothered. So instead, I designed and 3D printed colored inserts from shiny polyalchemy PLA. In perhaps not the most traditional colors, I didn't have a blue or a green shiny PLA, so I went with gray and purple, but it is what it is. When assembling these puzzles, I find it easier to start with the middle section and attach the 4 middle pieces, maybe loosely first, slide the parts in, and then go to the top, attach another middle piece, and then finally, when everything's together, you can lock the whole assembly up with a final middle piece on top, and then tighten everything up. And the colored inserts were simply glued in place with hot glue, except the ones covering the M3 screws, which were a press fit. And here she is, a 3x3 measuring 120 millimeters across and it's pretty darn heavy too. Actually, it's really easy to underestimate how much material goes into this. I ran out of black halfway through, so it's got this two-tone effect with the two different rolls I had. And if you're looking at printing this, you're looking at around something like this, 4 days of solid printing to get something like this actually 3D printed. But how well does it turn? Well, admittedly, I have a bit of a problem when I just dive into big projects without properly validating them. And in this case, yeah, not at all great. Not because the clearances are too tight, but in fact, they're too loose. I'm actually so used to giving my 3D printed parts generous clearances that these parts actually have too much play and they bind up against each other, which is unfortunate. If the puzzle's set on a hard surface, it actually works pretty well, but it still just has that issue of ratcheting and catching against each of the other parts because of that tolerance. So yeah, my bad. But hey, it looks pretty, right? Yeah, I know. I won't live this down unless I 3D print one that actually functions decently. So going back to the drawing board, I drastically reduced both the size of the puzzle and the clearances were reduced down to 0.1 millimeters to allow just a little bit of wiggle room for the texture of the FDM print. Strategic chamfers were put into place to make the puzzle more forgiving when misaligned, and I also redesigned the core and the middle cubies to allow for another vital ingredient, springs, just like the original Rubik's Cube. The addition of springs allows the entire puzzle to self-tension, and man, does it make a huge difference. Finally, I gave the resulting mechanism a generous hit of silicone spray. This is technically designed as a mold release, but any silicone spray should make a significant difference for the friction of the interlocking PLA parts. And this is the final result. This puzzle works way better than it should, considering I've done no post-processing to it at all. No sanding, no nothing. I just pulled the supports off. Now, I did waste all my black PLA on this one, so it's random colors, but it would still be fairly easy to sticker up or even make mini versions of the inserts like the bigger cube. And there you have it, my exploration into the mysterious mechanism of the Rubik's Cube. It's worth noting that I actually bought a new Rubik's Cube to tear down for this video to analyze the mechanism, but it seems the newer puzzles on the market actually use a different mechanism. It seems the world's moved on to more sophisticated and better approaches to create this movement. Plus, it probably has something to do with the original patent for the Rubik's Cube mechanism expiring quite some time ago, but I am stoked with this and it is definitely just the beginning. Here on Maker's Muse, it is my aim to empower your creativity through technology, and I have many more plans for 3D printed puzzles and mechanisms of increasing complexity in future, so be sure to subscribe so you don't miss it. And to address the question many of you guys will be asking in the comments, Angus, can you actually solve a Rubik's Cube? Well, no, not yet. I understand the method of solving them, I just haven't really fully learnt the algorithms involved, but I am working on it, so I'll update you guys in the next video on how I'm progressing with solving these, and I look forward to seeing you again very shortly here on Maker's Muse. Catch you later, guys. Bye.